Hey guys, welcome back to Infinite Math Help Squared. This video is going to go over adding and subtracting fractions, whether or not you have a like or unlike denominator. Inspired by my students, by the way, who I'm also going to shout out because they're showing amazing love and support. They're subscribing, they're encouraging me while I'm building this channel, and I appreciate them for it. So let's shout out 7th grade first. Shout out to Giancarlo, Valeria, Emily Mateo, Anderson, Alicia, Riley. Shout out to 6th grade for your energy and support too. Morgan, Dorian B, Christopher, Melanie. And if I didn't mention you, don't feel bad because I got a lot more videos coming and a lot more shout outs and love to show back. All right, let's get to these fractions. All right, so we'll start off simple. When the wholes are the same. Let's pretend I need $5 to go out. I know you're probably saying, Miss Leggett, you need a lot more than $5 in the year 2023, but let's just pretend. I need $5 to go out. I've got one in my pocket because I didn't spend it all today when I was supposed to at lunchtime. And then I go home and mom says, yeah, I'll give you 3. Well, that means that I have 4 out of the 5 I need. So there. That's adding like denominators. The whole was cut into the same equal pieces, and you just add up the parts. Okay, but what happens when it's not so easy? What happens when the denominators are different? Because that means that the wholes were cut into different pieces. Let's take something that we can relate to pizza. Okay, large pies are cut into 8 slices, typically. Okay, typically. I think I got this. They're supposed to be equal pieces. I didn't cut it right, but pretend that they're equal pieces and it's the perfect cut. And then personal pans are very small, very appropriate for, like, let's say a little kid. Instead of a Happy Meal, it's a personal pan. Okay, so then let's also pretend that for me, for my dinner, I ate 1 slice from the large. And let's say my kid is eating the personal pan and enjoying it, but then gets to the last piece and it says, Mom, I'm full. I don't want this anymore. And, Mom doesn't want to waste. She spends all this money and she doesn't want to waste it, so she just eats it. Well, someone says, well, how much did you eat today? I can't tell them 2 pieces because these were completely different sizes. So how do we rectify that? How do we fix that? We're going to fix it because we're going to make the wholes the same. What if this one that was a personal pan was no longer cut into 4? What if it was cut into 8 like the large one? All right, so mathematically, I can get to 8 by multiplying 4 by 2. And if I do that to my whole, I have to do that to the part, otherwise it's not equivalent anymore. Think back to your equivalent ratios, multiplying by the same factor to get to something equivalent. You want the recipe to taste the same, but maybe you want more. You want the color to stay the same, like the same light green or the same dark purple, but you need more or less of it, right? Equivalent ratios. All right, so let's find out what the new fraction is. This would be 3/8 plus 1 times 2 is 2, 4 times 2 is 8. And now I'm back to the original problem where my wholes are the same and I can just add up the parts. So what is 3/8 and a 4th? It's actually 5/8. Okay? All right, let's do one more because it doesn't always work out so nice that your denominator, one of them can go into the other one. Sometimes they're different and it takes a little bit more creativity. We'll also make it subtraction because we didn't do that yet. So let's say I want to take 4/7 and I want to subtract a 4th. There's that 4th again. Okay, so obviously 4 is not, I can't multiply anything by 4 to get to 7, at least not a whole number, right? So this means that I have to start trying to find something that they go into. Now, I can link you the least common multiple video, because in the least common multiple video, we were counting by numbers to find out what they had in common. 21 and then 28. So I'm skip counting by 7s. So I'll skip counting by 4s, 8, 12, 16, 20, 24, 28. You can stop when you find something that they have in common. So what's my common denominator that I choose? 28. Let's make them both 28. To get from 7 to 28, I have to multiply by 4. So we're going to multiply our numerator by 4. 4 times 4 is 16. To get from 4 to 28, I have to multiply by 7. So we're going to multiply our numerator by 7. So now, the new problem is 16 28ths take away 7 28ths. And 16 take away 7 is 9. So what's the final result? 9 28ths. Now, I'll link another video simplifying fractions, because this one cannot be simplified. But if it looked more like this, 9 over 27, then that can be simplified. And before you submit your final answer, you should be simplifying your fraction. All right? All right. Thanks again, guys, for all the love and support. Till next time.